Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we're going to be learning about the different forms of linear equations. Let's get started! The first one is slope-intercept form, and this should be a review because we've talked about it before, but if you're new to slope-intercept form, I have a video on it and you can go watch that through my channel. So, if you guys remember, slope-intercept form is y is equal to mx plus b. And we have two other variables other than x and y that stand for different things. And so the first variable we have is m, and the second one we have is b. So m stands for the slope. So if you ever have a problem and you need to put in the slope, you would plug in the slope for m. B stands for the y-intercept, and so for any of your problems, if you need the y-intercept, you would plug it in for B. So that was just like a quick overview of slope-intercept form. So now let's move on to point-slope form. So point-slope form is a little new, so we'll start off by showing what point-slope form looks like. So this is point-slope form, which is y minus y1 is equal to m times x minus x1. So the reason it's called point-slope form is because to be able to write a linear equation in this form, you need a point that will be on that line, not just the slope or in the y-intercept. You need an actual point that will be on the line of the linear equation. So again, we also have some different variables in here, so we'll talk about them here. So over here we have three different variables other than the standard x and y. First we have m, then we have y1, and then we have x1. So m is the slope, as it was in the previous one. Y1 is actually the y-coordinate of the point that you have to know that's on the line, like any point that's on the line. And x1 is the x-coordinate of that same point that was on your line. So, for example, if we knew that, let's say this point 3, 2 was on the line, right? So y1 would be 2, and x1 would be 3, because those are the respective y and x coordinates of that point. Now that we've kind of seen what point slope is, let's move on to standard form. So for standard form, this is what it looks like. ax plus by is equal to c. And again, we have some extra variables in here, so let's take a look at what those are. So the extra variables that we have are a, b, and c. So a is just the x coefficient, b is the y coefficient, and c is a constant term. So the constant term is just like the number. It's just like a plain number. So the x coefficient is a, the y coefficient is b, and the constant term, or just like the plain number, is c. So along with these, standard form actually has like a set of rules. It's a lot more stricter than point-slope form or slope-intercept form. So we will talk about the extra rules down here. So the first rule is that there cannot be any decimals or fractions anywhere in the entire equation. The second rule is that a can't be negative. So if you ever come across a standard form equation and a happens to be negative, all you have to do is just divide it by -1 so that a is not negative anymore. So b and c can be negative, it's just that a cannot be negative. So those are the two rules in standard form. Now that we've looked at slope-intercept, point-slope, and standard form, let's move on to the next page to do some practice problems with these three forms of linear equations. Now we have our practice problems, and problem number 1 says, write the slope-intercept form using the slope and coordinate point given. So if you guys remember, slope-intercept form was y is equal to mx plus b. So how we're going to start is just by plugging in all of the variables we know first. What we have so far is y is equal to, and then the next term is mx. So we already know m, which is the slope, so that's 3. So we're gonna plug in 3 for m, so we have y is equal to 3x, and then we have plus b. So remember, b is the y-intercept, but we don't know what the y-intercept is, so we're just going to leave that as b. So by using the coordinate point, we're actually going to find b. So how we're going to do that is we're going to take this point that's given and we're going to plug in the x value of this coordinate point for x in the equation and the y value for this coordinate point into y in this equation. That will just leave us with one unknown variable, which will be b, that we can then solve for. So let's start doing this. So first we have to plug in the y variable right here. So the y part of this coordinate point is 6. So we're going to say that 6 is equal to 3 times, and then we have x, and the x term for this coordinate point is 4. So we're going to say 6 is equal to 3 times 4 plus b. Now that we have this equation, we're just going to solve for b like we would solve for any other variable. So remember, the first thing you want to do is combine all like terms, and in this case we actually have to multiply 3 and the 4. So we're going to get 6 is equal to 3 times 4, which is 12, plus b. So 6 is equal to 12 plus b. So to solve for this, we get b alone on one side, so we can subtract 12 from this side and from the other side. And that's going to leave b alone on the right side, and it's going to have 6 minus 12 on the left side, which is equal to negative 6. So negative 6 is equal to b, or you can also write b is equal to negative 6. So now we know what b is. So what we're going to do is just plug in the b value to our original equation that we wrote in red up here. So we had already had y is equal to 3x, and now we know b, and we know that b is negative 6. So we can plug in the negative 6 for b right here like that. So now we have our final equation, which is y is equal to 3x minus 6, and that is the answer for problem number 1. Number 2 tells us the slope is 1/3, and it gives us the coordinate point 0, 12. So we're going to do the same thing we did before and write the equation with all of the variables that we already know. So we already know the slope, so that's going to give us y is equal to 1/3 x plus b, because b is unknown. So we're going to do, again, the same thing that we did in the previous problem and just plug in the coordinate points into their respective x and y values. So let's start by plugging in the 12 for y, that's going to give us 12, is equal to 1/3 times the x coordinate point, which is 0, plus b. So now that we have this, we can go ahead and solve for b. So b is equal to 12. So now knowing our b value, we again just plug in whatever our b value was back into the original equation we wrote up here in blue. And so that's going to give us y is equal to 1/3 x plus b. And we said b was 12, so y is equal to 1/3 x plus 12. And that is our final answer for this one. Let's move on to our third one. This one tells us that the slope is 5 and our coordinate points is 7, 0. So we're going to plug in everything that we already know, which is y is equal to the slope, which is 5x plus b, which we don't know. And then we're going to plug in our coordinate point values for the respective x and y's. So the y value of the coordinate point is 0, which is going to be equal to 5 times the x coordinate value, which is 7, plus b. So now we go ahead and solve this. B is equal to negative 35. So now that we have our B, we're going to rewrite the equation with the B plugged in that we had from the top, which is going to give us y is equal to 5x plus b, which is negative 35. So y is equal to 5x plus minus 35, which is just minus 35. So this is our final answer. Y is equal to 5x minus 35. Now that we've seen slope-intercept form, let's move on to problem number 2 for point-slope form. So we're on problem number 2, and you can see for each one we've been given a slope and 2 coordinate points. So for each one you can see that they've given us a slope, and for each one they've given us 2 coordinate points that fall on that same line. So remember, for point-slope form we only need 1 coordinate point in the slope. So we can actually choose which coordinate point we want to use to write the equation. So point-slope form is y minus y1 is equal to m times x minus x1. So we're just going to plug in everything that we know. So the first thing we want to do first though is decide which one we want to use. So for this one we can use the first one, which is 3, 4, and now we'll just plug in everything that we have. So we're going to start with y minus y1, and since we're using the first one, y coordinate of 3, 4 is 4. So y minus 4 is equal to m, which is the slope, which is going to be 2, times x minus x1, and x1 is 3 over here. And so that's it. It's that simple. That is the point-slope form, because all we needed was the coordinate point and the slope. So for our next one, we can do it the same way. And so we're going to choose which point we'll use, and I can use 7, 0, this one. So we have y minus y1, which y1 is actually 0. So y minus 0 is equal to m, which is negative 3, times x minus x1, and x1 is 7. So x minus 7. And so this is our equation, but of course we have y minus 0, and that really isn't necessary. So we can just write y is equal to negative 3 times x minus 7. And that is the point-slope form for that one. For our last one, we can use 12, 8 as our coordinate point. So we'll write y minus y1, which is 8, is equal to m, which is 1, times x minus x1, which is 12. But since 1 just gives like the same value of x minus 12, we don't have to write that 1 over there, so we can just say y minus 8 is equal to x minus 12. And that will be our point-slope form for this one. So now that we used point-slope form, let's move on to problem number 3 to find standard form. So problem number 3 tells us to rewrite the equations found above into standard form. So the first equation that we had found from up there was y minus 4 is equal to 2 times x minus 3. So if you guys remember, for standard form, what we have to do is get the x and y terms onto the left side of the equation, with the x term coming first. And we have to have the constant term, or the number that's just like a plain number, onto the right side of the equation. So we're going to start by just moving everything to the left. And to do that, first we're going to have to distribute this 2 to the x and the minus 3. So we're going to do that, and it's going to give us y minus 4 is equal to, and then we're going to distribute 2 times x, which is going to give us 2x, and then 2 times negative 3, which is going to give us minus 6. So now we have y minus 4 is equal to 2x minus 6. Next, what we want to do is get the x term onto the left side and the constant term on the right. So first I'm going to move over the x term to the left side by subtracting 2x from both sides, which is going to give me y minus 4 minus 2x is equal to 2x minus 2x cancel out and leaves us with minus 6. Now I'm going to add 4 from both sides to get the constant term on the right, which is going to leave me with y minus 2x is equal to negative 6 plus 4, which is going to be negative 2. And now remember, the x term has to come before the y term. And so I'm going to rearrange this so that the x term comes before the y term, and that's going to give me minus 2x plus y is equal to negative 2. Now, if you remember, one of the rules for standard form was that the a term, or the term that's in front of the x, can't be negative. And so all I'm going to do to get rid of that is multiply both sides by negative 1. And so that's going to end up giving me 2x minus y is equal to 2. So this will end up being our final answer for this one. 2x minus y is equal to 2. And that is the standard form. So let's move on to the next equation. So for the second one, the equation we had gotten from before was y is equal to negative 3 times x minus 7. So we're going to write this out in standard form. But remember, first we have to distribute. We're going to start with y is equal to, and then we're going to distribute negative 3 times x, which is negative 3x, and then negative 3 times negative 7, which is plus 21. Now that we have this, we want to move the x term to the left side. So I'm going to do that by adding 3x to both sides. And that's going to give me y plus 3x is equal to, that's just going to leave me with 21 on the right side. And remember, the x term has to come first. So I'm just going to rewrite the right side to say 3x plus y is equal to 21. And now that this is in standard form, we can say that this is our final answer. 3x plus y is equal to 21 is our answer. Let's move on to the last one. So for this one, the equation we had gotten was y minus 8 is equal to x minus 12. So for this one, we actually don't have to distribute, but we do have to get the constant term to the right side and x to the left side. So I'm going to first start by getting the constant term to the right side. You could start either way, it doesn't really matter. And remember that our x term has to come first, so I'm going to rewrite this as minus x plus y is equal to minus 4. And now if you see here, our a term, or the number in front of the x, is negative. It's negative x, and the a term cannot be negative. So what we're going to do is multiply everything by negative 1, like we did in the very first one. We're going to end up getting x minus y is equal to 4. So this x minus y is equal to 4 is our final answer. So we finished all the practice problems, and I hope everything made sense. If you liked my videos, please like and subscribe. Also, be sure to follow me on Facebook and on Instagram, and to comment any questions you have on this topic or any topics you want me to cover in the comment section below. Thanks for watching. See you next time. Bye!